I want to update you real quick on our pulse results. I just have to go over here so I can see. Okay, 26%.
Do you think the Second Amendment is outdated?
26% say yes, 74% of you say no, it is not outdated. Thank you for weighing in on our poll. All right, Keith.
All right, got a lot of science today, so we're going to get right to it. I love when people call. This is actually a call or write in with questions for BrainDrops. Let's get to the question, which was, he said, years ago I read that I'll weigh less in Florida than I do in Maine. Is that true? The answer is yes. Now, it's not a ton, but there is a yes answer to this. You'll weigh less as you head closer to the equator. And here are the forces at work when you talk about how much you weigh. Your mass is always going to be the same no matter where you are. So when you talk about weight, the Earth's gravity, Sun's gravity, Moon's gravity, and Earth's centrifugal force. Now, all of these are going to be constant. The Sun's gravity and the Moon's gravity, relatively small forces on us. In fact, I had to write this down. 3 5,000ths of Earth's force is what Sun's gravity is on Earth. So it's pretty negligible. The two things that change as you go towards the equator, Earth's gravity and the centrifugal force. So let's move on to our next nerd graphic, which is the Earth is not totally spherical. No, it's not flat, but it does have a bulge in it that's about 24 miles on total. So what that does for you is it changes gravity. Remember, gravity is directed towards the center of mass. So if you're farther from the center of mass at the equator, there will be less gravity. So if you're at the pole and your weight is 175 pounds here, the force of gravity downward is going to be different. It's 9.814 meters per second squared at the equator versus the pole. So you've got a little difference. Don't give me that face, Lee. We're not even done yet. It's going to be a little bit different on the equator. It's going to be less. Now, when you're at the poles, you can see the downward force is 9.832. So you're talking about just decimals here.
Right.
Okay, so automatically, if you take the equation in, you're weighing a little bit less at the equator by 0.4 pounds compared to the poles. Now, the other force is the centrifugal force, which is the Earth spinning. So at the equator, that's a net vector up. At the poles, there is no centrifugal force because you're standing, think about it, you're standing where the Earth is rotating. So at the end of the day, the bottom line is it's not much, but you weigh 0.53% less at the equators than you do at the poles.
And now we have the term equatorial bulge.
Equatorial bulge. But remember, your mass is the same, so you're going to look the same in the mirror.
Lovely. That was a lot to handle. And News Center at 5:30
what just happened? What happened?
right now.
What happened?